Hey guys, welcome to this video. So in this video we will be discussing the solution of the problem which I gave you in the morning. So let us begin. Now this is the figure in your question. The question asks you to calculate the settlement of the footing. Okay. So now if you observe carefully, we have got a strip footing which is having a width of 1.2 meter. There is a groundwater table at a height of 1 meter from the ground level. The entire soil is actually clay, okay, and just beneath the footing we have got another clay layer which is having a height of 6 meter. Now if you observe above the water table, the bulk unit weight of clay is given as 18 kilonewton per meter cube, and beneath the footing we are having some additional soil properties such as the compression index which is 0.08, initial void ratio given as 0.40, and the saturated unit weight of the soil as 20 kilonewton per meter cube. So with this data we need to calculate the settlement of the strip footing. So let us see how to do that. Okay, so the first thing that you need to decide is which formula you are gonna use to calculate settlement, because you see we have got many formulas to calculate settlement. Now the initial hint that is given to you is CC. CC is being given to you. Compression index we know is used only for NC soil. So definitely the formula to calculate settlement will be the one which is used in NC soil. So this is the formula that I will be using. Okay, that means it is CC by 1 plus E naught into H naught into log of sigma naught plus del sigma dash by sigma naught dash. Okay, so let us see what are the requirements of this formula. We first need to know what is CC. So this has been given to you, which is 0.08. Then we need to know what is E naught. This is also given to you, it is 0.40. Now the next term which we need to know is H naught. So H naught is the initial thickness of the soil mass. Now here comes the big challenge in this problem. Okay, so now if you observe in the figure, we have got two heights of soil. One is 1 meter up to the groundwater table and the other is 6 meter, okay, just beneath the footing. So the question is, should you take 1 plus 6, that is, should you take 7 meter as the initial height, or should you take only 1 meter, or should you take only 6 meter? The answer is you should take only 6 meter as the initial height of the soil layer. Why? You see, settlement is something that is always calculated beneath the footing. Okay, so now my thickness of the soil layer beneath the footing is what? It is 6 meter. So this becomes my initial height, that is 6 meter. Now here is an additional information. Suppose the same footing is now resting over two soil layers. Okay, I have got one layer of sand which is denoted by S, and the other layer is of clay. Alright, so the sand layer, it has got a height of say 2 meter, and now clay layer has got a height of say 4 meter. Now if I ask you what is H naught in this case, your answer will not be 2 plus 4, that is, it is not 6. Okay, if you say 6, it is wrong. Why? You see, sand is something which do not undergo consolidation. You know that permeability of sandy soil is very high. Okay, so if you apply some amount of water in a sandy layer, the water will quickly drain out. So the sand does not get any chance of undergoing consolidation, right? So you have to neglect the layer of sand in this case. So if I ask you what is H naught, it will be simply the thickness of the clay layer, that is, it will be only 4 meters. Okay, so this is something which you should keep in mind while solving numericals, that sandy layer of soil is not considered while calculating consolidation settlement. Okay, now let us come back to the problem. So I have fixed that H naught in this case will be 6 meters. Okay, now I need to know sigma naught. So what is sigma naught? Sigma naught is actually the initial effective stress. That means before the construction of the footing, what is the stress applied in the soil layer is what is known as initial effective stress. Now the thing is, where do I need to calculate initial effective stress? At which depth? Okay, so that is the main question. So you see, settlement is always calculated at the mid height of the clay layer. Okay, this is the another important thing which you need to know, that this is my clay layer, that is which is having a height of 6 meter. So settlement will be calculated at its mid depth, that is from here to here, at a height of, say, that means at a height of 3 meter beneath the footing. Okay, so I will be calculating the settlement at a height of 3 meter beneath the footing. So since I am calculating at a height of 3 meter, I need to know what is the effective stress at this height, at the height of 3 meter. Okay, so that is what I have written over here, that settlement is always to be calculated at mid height of the clay layer. In this case it will be 3 meter from the base of the footing. So how to calculate effective stress? So from module 2 you know that effective stress is the difference between total stress and pore water pressure. So let us first see what is the total stress at 3 meter depth from the base of the footing. So now if you observe in the diagram, just above the groundwater table, the bulk unit weight is 18 kilonewton per meter cube. So 18 multiplied by 1 will give you the total stress up to this height, right? So that is what I have written, 18 multiplied by 1 is the total stress up to the bed of the footing. Okay, now beneath the bed of the footing, what I have got? I have got bulk unit weight of 20 kilonewton per meter cube. Okay, and what is the depth? The depth is 3 meter. So 20 multiplied by 3 will give you the total stress beneath the bed of the footing. So if you add both of them, you will be getting the total stress at a height of 3 meter below the footing, right? Now what will be the pore water pressure? So pore water pressure is something which is exerted by water. Now where is water located? It is at the bed of the footing, right? So the pressure exerted will be from the bed of the footing to 3 meter, right? Now what is the unit weight of water? It is 9.8 kilonewton per meter cube. And what is the height of water in this case? It will be 3 meter. Okay, so 9.81 into 3 will give you 29.43 kilonewton per meter square. So if you subtract both of this, you will be getting the effective stress, which is 48.57 kilonewton per meter square. Okay, so I have calculated initial effective stress, that is I have calculated sigma naught dash. Now the next term which I need to know is del sigma dash. So del sigma dash is change in effective stress. Now when there will be a change in effective stress? When the footing will be constructed, right? So when the footing is constructed, the question says that the effective stress generated is 40 kilonewton per meter square. So I have written change in effective stress is del sigma dash, which is 40 kilonewton per meter square. So you see, I have known all the parameters required in the formula. So now I can easily calculate the settlement. Okay, so now I simply put the values. So Cc is 0.08, E naught is 0.40, H naught is 6, sigma naught dash as calculated is 48.57, del sigma dash as per question is 40, and then I calculate. Okay, so this is the settlement in meters, 0.08945. So if I convert it into millimeters, it turns out to be 89.45 millimeters, which is roughly equal to 89 millimeters. So this matches your option C of the question. Okay, so this is how I solve the numerical, right? So that's all for today. Thank you.